and Economic Development Department. I'd like to talk to you today about visualizing data and show you how to load data from the Community Data Program into ArcGIS Pro. So why is it important to visualize data? I'd like you to imagine a scenario that you just got your custom census order from CDP, and you're really excited by the results and what it says about your community. How would you communicate that to other people who aren't as familiar with the data? You could show them the table itself, which is often how we receive it. This may be good for doing analyses and comparisons, but it's not easy for our eyes to take in, especially when it's a big table. In addition, there's no easy way to show which rows represent which area without adding a bunch of extra location columns. If we show it on a map, we might not be able to show as many different attributes, but it can be a lot easier to understand and also to see patterns. This is a choropleth map of apartment density. On this map, it's easy to see that there's more apartments per hectare in central Oshawa and especially clustered along a north-south street. And if you're from the area, you'll recognize some of the clusters as downtown Oshawa or Oshawa Center Mall and Durham College or UOIT. And you might even notice outliers like the White Oaks apartments in West Whitby, which stands out as a small block of towers in a sea of low-density housing. So I'm going to show you simple steps to make a basic choropleth map, which is a map of different shaded polygons over a geographic area. First, we're going to find and prepare the data outside of ArcGIS. We need to find the data we want. We need to prepare it to show the attributes and dimensions that we want. And then we need to arrange the data into a table that has one row for each of our locations and a column that we can join to the geography layer in ArcGIS. Then we're going to go into ArcGIS Pro and find the geography we need, add our data as a table into the ArcGIS project, join the data to the geography, and then explore the results. I'm going to jump in and out of the presentation as we go to show you some of the workflow. Please feel free to interrupt me if you have any questions. First, we need to find your source data. For example, why not start by looking in the Community Data Program? Make sure that the data you find matches the geography you have. If it's custom geography, you need the same shapefiles you submitted to the CDP. For this example, I found a table of housing and demographics by census dissemination area from CDP. I made sure that it had the dimensions and data that I wanted. In this case, I want to show how many dwellings there are in each area by the different structural types of dwellings, like townhouses versus apartments. Next, prepare your data in Beyond 2020 if it's an IVT file. My goal here is to make a flat or denormalized table that has all the attributes I want across the top and a row for every geography along the side. You can use Beyond 2020 to arrange and drill into the different dimensions, but I wanted to keep everything to the totals and just show the number of dwellings by tenure, which is the top row, and by structural type, which is the second blue row. I'm going to jump into Beyond 2020 now and show you an example. So please bear with me. I'm going to jump over here into Beyond 2020. You should still be able to see my screen. So here you can see the, thanks Sadie. So here you can see that I've got this table from CDP and I've got a bunch of different dimensions here that I can use. I've got them all set. So here, like age of primary maintainer set to total, condominium status is set to total, household type is set to total because I don't want to accidentally filter my results. I've got two dimensions here on the top, tenure and structural type. You can switch the locations of these by dragging the box up or down, and now you see structural types on the top and tenures on the bottom. But I want tenure to come first because it'll make it a little simpler because there's fewer tenure options than there are structural types. Geography is also one of the dimensions, and I've got it here on the left side. You can drag other things into this, but I want to show geography because I want one row for each of these dissemination areas. Okay, now I'm going to go back into the presentation. That should work. So we're going to save what we just saw in Beyond 2020 as an XLS or a CSV file so we can open it and explore it. You can see that the table will show extra information at the top about the other dimensions in the table, as well as a row for both dimensions that I want. This might make sense here if you're looking at it in a table, but it's not how ArcGIS needs the data. Oops. First, we'll have to make a single header row, in this case by simplifying and concatenating the other dimensions. This can be as simplistic as you like, as long as no two are the same. Second, you'll want to make sure that there's a column which just has the IDs of the geographies you want. I'm using a layer of dissemination areas where the ID is just a DA number, but it's stored as text. Then hide or clear out the old headings and any working rows you had, and you're ready to import it. Note that this table here only has one row of headers across the top, and it has one row for each different DA. I'm going to jump into Excel and show you how I would do that. There. So this window here, this table here, shows what it would look like when it comes from beyond 2020. You can see I've got two different dimensions across the top. I'll make this one wider so you can see it better. So the top one's for tenure and then for structural type. And on the left side here, I have all these geographies, but they're not just the numbers I need. They have extra information like percentages and stuff beside them. So what I would do is I would add additional columns and rows here with the formulas I want. To save you from looking at my Excel workflow method, I've got this one here that shows what I added. Everything I added is in light blue, so you can see it more easily. First off, to make the geographies more comprehensible and to be able to join them to the layer I have, I isolated just the front part of each of these text box here. This is just two text commands in Excel. There's a trim command and a text before command. Basically what this does is it gets rid of the leading spaces and any extra spaces and takes everything from before the first space. So what that ends up with is just the 8-digit DA ID, which is what I want. And it's also formatted as text still. It's on the left. That's good. And then here for the friendly headers, I wrote in by hand what I wanted this one to say instead of total tenure. Say all tenures, and then if you look over here, it has owner, and if you look over here, that's renter. And then I made a formula here that just sticks these two text fields together because I wanted it to just be on a single row to have all the headers. This takes the tenure one I made and sticks it to the existing dwelling type one. So now I have a single row of all the different types and tenures and structural types. And I've got a single column which has all the geography types I need. Then I made a copy of that table and dumped it into a fresh worksheet. I called this worksheet for ArcGIS. And here you see this doesn't have formulas anymore. It just has the actual values. So I've got my row of different attributes along the top and my columns for each DA on the bottom. So now we're ready to put this into ArcGIS. So I'll go back over here. Okay, we did that. Okay, so now we're going to open ArcGIS Pro and find our geographies. I started by making a new blank project, but you can also import them into an existing one. Hopefully you have your geographies already, but here's a link to some census boundaries if you need it. So first, we're going to add the feature layer to the map and make sure it's what we want. I see dissemination area boundaries in my area of interest, which is Durham region. Next, we're going to explore the attribute table to confirm that the shape IDs here will match the way I have it in my data table from CDP. In this case, the DAUID column is showing 8-digit numbers formatted as text, which is the same as my data table. I'm going to jump into ArcGIS Pro here to show you what I'm talking about. Go there. Oh, so this is what I made ahead, but I'm going to show you actually how we do it. So here, I already have my layer of dissemination areas loaded into the project. It came from my software data environment. But you could find this also from Statistics Canada or other sources. And I'm going to right click on it. Oops. I'm going to right click on it here and I'm going to go attribute table. And then you can see the attribute table here at the bottom, which has all the different this has the different data and the different information for each dissemination area. And you can see the DAs here are 8-digit numbers formatted as text. That's what I want. Okay, let's see. Okay, and now I'm going to go back into the presentation here. And just to make sure, hope anybody doesn't hear a whole lot of background noise. I apologize if you do.
All good.
Okay, so now I'm going to open ArcGIS. Oops. So now we're going to add the census table to the project. So first, we're going to use the Add Data button to find your Excel file. And navigating folders in ArcGIS Pro can be weird. So I usually just copy the file path from another explorer and drop it into the selection box to speed things up. You can also save the table in the ArcGIS Pro project folder, which is a lot easier. So make sure you add the right table. If you have an Excel file with a few different tabs or different named table ranges, make sure you pick the one you actually want. Here, I gave myself instructions by naming the table range for ArcGIS. Next, we're going to open the table in ArcGIS Pro to make sure that it came in properly. Check to make sure that the attribute names are what you want and that the geography attributes will work. Here, I see my DA IDs are 8-digit numbers formatted as text, so that's good. The extra rows like Canada and Ontario there, they're fine as they won't get joined. So I'm going to jump into ArcGIS Pro and show you how I do that. Let's see here. So here I am in ArcGIS Pro, and there's a few different ways that I can add this table. I've got the table here in under my list of folders, and I'll also see if I can show you how to do it through the Add Data button. You can hit Add Data, Browse, and I copied in my file path there, and then here you see for ArcGIS, that's the one I want. And if I hit Open, it'll show me the different data sheets or named table ranges. And here's my for ArcGIS one. I hit OK, and now it should come into the project. Here it is, and it should work. I'm going to right click on that, and I'm going to click Open. Here we go. Good. I see my data table here for all the DAs. And again, I see my numbers here on the left for each geography. I didn't call this attribute here like DAUID or something like that. I could have, but I can give it any name I want as long as I remember that's the name I need. So now we'll go back into the presentation. Okay. So now we're going to join the two together. So it's important to start from your featured layer of geographies. Otherwise, it won't join correctly. You'll just end up joining your geography information to your data table, and it won't show up in ArcGIS. You want to do it the other way around. So we want to select the layer, the geography layer, and add a join. So you can see there over on the right, that's the button to hit Add Join. Now you have to select the table you want to join and make sure that you select the fields that have the geographic ID key. Validating the join is a good idea to make sure that the join will be successful. Now you can run it. So ArcGIS Pro gives you a message output, and this one says, oops, pardon me, jumped ahead. This one says that it has joined 1,004 records. That's good because my input table has 1,004 rows. So it means it found something for all of them. You can see the join table has had many more rows. This is a reminder to make sure that that's what you were expecting. If the table is really big, you can find a way to filter it down to the geographies you want before you bring it into ArcGIS. For example, if you were using the Statistics Canada census boundaries file that had all of Canada, you would want to use a data query or something like that to only bring in the ones you wanted. So now I'm going to jump into ArcGIS Pro here and show you how I do the join. So let's go back to ArcGIS Pro. So now I want to start from here. I want to join the table to this. I can right click here and I can go to joins and add a join this way, or I can do it the way you had here. I think, let's see. Oh, let's do it that way because the sharing bar is getting in the way. Well, maybe I can do it this way. No. The data joins. Okay. There's a lot of different toolbars in ArcGIS Pro. Here we go. Add a join. And now it's going to bring up my dialog box. Okay, so I want to add dissemination areas. I need to find the DAU ID is the one I wanted. And I'm going to join to the for ArcGIS join table. And then the geography SDE is what I want. The input table is the one that's going to have the attributes joined to it. So that's why we want that to be the geography. The join table is just the table where everything gets moved over. And we want that to be the data table from CDP. I want to keep all input records so that it doesn't accidentally delete anything. My join should be 1-to-1, but I'll put 1 to first. And I'm going to hit validate to make sure it doesn't break. I hit validate. And okay. And here it says it's going to match 1,000 records. That's good. Now I'm going to hit OK. Adding the join, and it says the join is completed. Okay, so that should be ready to go. I'm going to open this attribute table again to see if it has. Now the attribute table should have a whole lot more attributes on it. And there we go. There it shows all the information from the CDP, from the data table, added to my geography here. Okay, let's go on the presentation here. So now it's time to explore the results. The census data fields will now show up as attributes in the featured layer table, as I just showed you. So now we can use the symbology tool, and we can pick graduated colors for a choropleth, and it'll want a numeric attribute, and we can see what the data tells us. Here, I can see how many apartment dwellings are in each dissemination area across the Durham Lakeshore. This is just a flat, the higher the number, the more red it is here. For bonus points, you can use the normalization dropdown that's in the symbology tool to normalize results by something like area. So you'll see the results as a density instead of as raw numbers. This is good for when you have features with widely differing sizes, like urban versus rural dissemination areas. You can see looking at this, there are dissemination areas that are hundreds of times bigger than other ones. The rural ones are gigantic, and the ones, for example, in downtown Oshawa are really small, and which represents the difference in density. So in this case, what you see here, I've made this look as density. So it's normalized it by the area of the shape so that you can see the density of apartment dwellings in across Durham Lakeshore. So you can see some of the areas that were darker before are now much less after you spread it out. So I'm going to jump into ArcGIS Pro and show you how I would do that. There we go. So back to ArcGIS Pro. Here we see, so I can close this now or make it a little smaller so I can see my region. Now I'm going to right click here and I can hit go to symbology. And there's other ways to get to symbology. Right now it's a single symbol. Everything's just a green box. That's all it is. Depending on the type of layer you have, if you have nominal values, you can use unique values. So if you have category attributes that you want to show, but here we want to show by quantity. So I'm going to go to graduated colors. And then I'm going to pick a field. So already it picks sort of just a default field for me. So this is total number of dwellings right now. Let's show for fun, let's show rental apartments. So here, 5 or more stories. We're going to say rental apartments. You can see there's not a lot here, but we can explore the results now by zooming in, and we can see where the taller apartments are in Durham region. There's a few in Whitby and Oshawa, there's a few in Pickering, and there's a few in Ajax, but that's about it. Now I'm going to show you how I'd normalize this by area. I'm going to click normalize. I'm going to go to the field that I know has the area of the UID of the dissemination area. Usually featured layers always have this sort of shape.st area thing in it. This is usually meters squared. So it's not going to show in a nice density per hectare thing, but at least it'll still show what I want. And you can just do the multiplication to see here. So you can see North Oshawa has dense apartments and some areas along Central and South Oshawa. And here's White Oaks that I was showing you about earlier. So now this is an area that you can, or this is a way that you can explore your data. Let's go to something that might show a little more interest here. Let's see all row houses. There we go. So now this is showing density of townhouses in Durham region in the Lakeshore municipality. You can see a lot of it's in the periphery areas. Okay, that's how you show, that's how you can show information, a layer with a choropleth. You can also make it a little bit transparent if you want to see what's underneath it. Say you want to be able to show the labels or see the streams underneath, that sort of thing. Let's see, do that so you can see it. Okay, that's that. I'm going to go back to the presentation now to finish up. So we went through, we used symbology to pick a feature to show, and we used area to normalize it. So please note, this was just a simple demonstration and a simple visualization. There's so much more to explore. There are many ways to visualize and explore data, both in ArcGIS and other tools. Try exploring different visualization options and analytical tools to do more with your data and tell compelling stories. This can include non-map tools like charts and graphs. And sometimes all you need really is just a simple table. Remember to pay attention to how you visualize your data because other people might not see it the same way you do. Beware of accidentally showing something as bad or undesirable, or accidentally painting a whole neighborhood in a negative light. Here's some resources to help you. Esri has a lot of good tutorials for how to do this stuff. And that's how I learned. As mentioned before, I've only been doing this for a couple of years. Also, here's an online textbook about urban data analytics. I've been taking a course in this through U of T, and it's been eye-opening. Anyway, that's my presentation. Feel free to ask me anything, and thank you very much for your time.
Thank you, Graham, for the great interactive presentation, going back and forth. I'm sure that's not easy to kind of going back and forth presentation to the demonstration of the Excel Beyond 2020 and ArcGIS Pro. So I appreciate that for doing it very well.
My pleasure.
So if anyone has any question, you can put it in the chat box. Also, you can raise your hand and speak to it. There is a question about the textbook, Graham. Said that if that textbook is freely available online, can you drop the link into the chat?
Yeah, I should be able to. Just do this right here. I still have my screen share on so you can see it all. Okay, it's the Urban Data Storytelling Textbook from School of Cities. It's my understanding that it's freely available. I didn't need to log in to access it. I'm going to go over here and go into the chat.
If the link is in the presentation slides, so we'll share the presentation slides as well.
Yeah, and the link is in the presentation slides, as is the link for a couple of the other things as well. So you should be able to see that. I hope I don't get in a whole lot of trouble from U of T, but we'll see.
Okay. A question asking, are data available to public? And then a general question about the tutorial about cartography.
Okay. There's a lot of data available to the public. One of the things actually is, let's see, I think in this actual online textbook, there's a lot of really good, there's a link here for somewhere for a lot of data that's available here. I'm just trying to read and talk at the same time, and I cannot do that. There's a lot of good open data. For example, I live in Durham region, that's where I work. I can go to my regional municipality's open data website and get some information. Dissemination boundaries, dissemination blocks, I think I could get, and health neighborhoods and that sort of thing. Depending on the type of data you want, there's a lot of available things. I think Ontario's Geo Hub, I think Geospatial Ontario has a lot of information. Just trying to think of that online, but yeah, there's a lot. And as for tutorials, I think one of the links I put in this thing here is mapping and visualization in ArcGIS Pro, which hopefully ArcGIS Pro has a whole lot of tutorials that you can do online. A lot of them are free. Some of them cost money. But I've made pretty good use of a lot of the free ones because a lot of this has had to be self-learning because I've had very limited GIS education, like when I was doing my urban planning masters or anything like that. So I had to learn a lot of this stuff on the job.
Perfect. So question asking about that great work. Do you ever have problem with UID fields in census data file importing as a string vs double fields and them not joining the features UID correctly?
Yeah, that's a good question. That's why I mentioned that a few times. It can be really frustrating to change a data type, like change an attribute type in ArcGIS Pro once you already have the information. Let's see. So here's my hopefully you can still see. Yeah, here's my data table that I brought in. Say, for example, that the DA IDs here had all come in as text and not as, or had all come in as numeric and not as text. I can go to the fields view. Oh, wait, I can't. I can sometimes go into a fields view. I can go into a fields view for some things and try to add a new one. But it can be pretty tricky to try to force something in ArcGIS to be the thing you want. Now, that's for me. I'm not trained in ArcGIS Pro all that well. So other people know how to fix this. One thing I do know pretty well is Excel. So in Excel, if something starts as text and you want it as a value, well, there's a function for that. And if it starts as a value and you want it as a text, there's a function for that.
Awesome. So just a note that we will kind of take the questions until 11. Sorry, that's a BC time. So until 2:15 p.m. And then we start with the QGIS presentation. And at the end of both presentation, if there's time, we again go through the question and answers. So the next question asking that has AI help with the integration between Beyond 2020 and ArcGIS?
I don't think I'm in a really good position to answer that. I haven't tried using AI very much. I know that AI, like you can see the Copilot button on my screen here on Excel. I know that Copilot apparently is pretty good at cleaning data, but I haven't tried that too much. So sorry, I don't know.
The next question asking that does ArcGIS automatically apply underscore to spaces in the field names when you import? I was always under the impression that you needed to replace spaces with underscore in the Excel data headers before importing into ArcGIS. Thanks.
That's probably a good idea, and I probably should have done that. I've put my mouse over the header here in the table that I imported. So you can see that it looks like it looks like it has all spaces, but if you hover over it, you see that's just the alias. And ArcGIS Pro just sort of assigned it a field name, which has like underscores instead of spaces. I bet if I go to the next one, it'll probably just, there we go, all tenures single detached. Yeah, so it's just fixing it for me, sort of. I think there's people in the office with me today that would probably be scowling at me for my etiquette here with using ArcGIS Pro. But for this, I haven't had too much trouble with this. If I'm making things inside ArcGIS, say I make a new field because I want to calculate something like turn the meters squared into hectares, then I have to make sure that I'm not using spaces or anything because it can really mess up. And I've had all sorts of weird errors with ArcGIS with having illegal characters inside attribute names or inside file names.
Do you have any tips for cleaning, manipulating data in Excel? Sometimes I find it a bit challenging to format the data from Beyond 2020 properly before loading it into ArcGIS. Thanks.
Yeah, I have some tips. Similar kind of thing. Like I spend a fair amount of time in documentation, on documentation things for Excel, and I use Power BI a lot for this kind of cleaning and manipulating. If I wanted to do anything beyond simple additions or simple kind of text manipulation here, I would probably bring it into Power BI where I can do a lot more with it, especially if you're trying to synthesize information from more than one table. Um, yeah, say you have like census data that you want, but you also want to um, make a delta between that and development applications or new housing that's in the development pipeline or something like that. I wouldn't try to do that in Excel, just because it gets really messy when you have multiple tables. And and so if you have more than one table, I would use Power BI to make a simple kind of denormalized table that has all the information you want. But I use concatenation a lot. So as you can see here, um, I made like this formula here. It's a really simple looking formula. It just takes that one and adds that one. So knowing simple things in Excel, like the ampersand is the same as the concatenate function, sort of. It turns the concatenate function into an operator. Then you can just type the one source you want, do the concatenate button, like so ampersand, and then type the little delimiter that you want, and then another ampersand button, and it'll do it for you. That kind of thing, I use a lot when I'm getting like multi-dimensional data or data that has like, for this example, tenure and type. If it's just a single dimension, like if I just wanted tenure, just total households by tenure, it would have been easier, right? I wouldn't have needed to add these two together. For this kind of thing, it can get a little more tricky where we have the geographies. But again, this is a pretty simple function. This is a pretty simple Excel formula here too. You just have to like start from the inside of the brackets and work your way out. So I want that cell. I want it trimmed to get rid of extra spaces. And then I want the text before the first space. And so again, like there's a bunch of different ways you could probably do this, but this is pretty simple and it's fast because this is already in text format. I hope that answers your question. Be humble and check online to look to see if there's other options. Because even though I've been using Excel since since the mouse was just a flashing block, that doesn't mean I don't have more to learn.
Awesome, great tip. Question asked, have you worked at all with the time series historical demographic data in a GIS environment? Any tips or insight?
That's a really good question. Again, with my experience with time series stuff is fairly limited. I did take a few courses in visualizing data that had a lot of really cool stuff you could do with time cubes or something where you'd have a three-dimensional visualization of data with stacks of cubes, basically, to show you an information like crime rates or something like that. And then each layer of the stack would be like a different year or something. So I've seen those a bit, but I would say check online for tutorials on how to do that.
Awesome. Okay. And then the last question you already mentioned that in the previous question, so that's awesome. There is another question that says, in your GIS prepared data in the Excel, does it have the geolocation example lats and long to help you visualize that, or is there an alternative to lats and longs you can use?
Okay, that's a good question. In this case, I didn't need the lats and longs because I'm basically relying on the relying on the feature layer I have to have the geographical information. And then that's why I did the join. So I joined the tables so that I can basically put the tabular data that I get from CDP into the feature layer that has the geographic location. If you were to add lats and longs to your data, then you wouldn't need a feature layer, but you might only bring it in as points. So you might make a bubble map that way if you have lats and longs. Now, depending on the type of map you're using, that could change the format you need to use. Often, in my organization at least, we need to use either decimal degrees or UTM. And I think I might be getting this wrong, but I think in ArcGIS Pro for us here, we often use UTMs, which can create a problem because when I'm doing stuff in Power BI, it generally wants to use, like decimal degrees for mapping in Power BI. It can get complicated. Ask your GIS people, or if you're just doing it yourself, I did a bit of looking around on forums and stuff to find ways to convert like from UTMs to lats and longs and that sort of thing, or from UTM to decimal degrees. So it's complicated. Hope that answers the question.
Thank you for that. Okay, so if you have any questions, please post it in chat box. We actually kind of something we usually do at the beginning of the webinars is having a poll asking you about your kind of level of comfortability with data and GIS. So I'm going to launch it now. If you can respond it, we open it in kind of 1 minute until it will be kind of answered. So that help us to understand our kind of our members, and then the needs, and we can have design kind of webinars that fits your, that meet your needs and will be helpful for you. And after that, we will start the QGIS presentation, and hopefully we have another question and answers. Perfect, just 15 seconds. For the responded, if you can check it out and responded, we appreciate that. But and then I will show you the results at the end. Perfect. So ending the poll, sharing the results. So we see that 50% of people here in this webinar are very comfortable with data. So they said, I'm a high capacity user. I work with data regularly. Data analysis is part of my job description, and I'm very comfortable with software like Excel beyond 2020 and ArcGIS. 38% somewhat comfortable and 13% less comfortable. So thank you so much for sharing with us. And with that, I would like to share my presentation with you. Just maybe get some help from Graham that or anyone in the room that you can see the presentation slides.
Yeah, looks good.
Perfect, thank you. I kind of I've been working with QGIS for a long time, and my background is urban planning and geographic information systems. I used to work with ArcGIS, ArcGIS Pro full time. Now I kind of switch. My role is not a GIS kind of person, but I still do some part-time and casual QGIS work because, that's something like works for my kind of my career right now, because I don't have a very full-time work in GIS. So QGIS is an open source data, and if I want to do some kind of contracts or casual work, QGIS is the best, but also really like that the user friendliness of ArcGIS Pro. So that's the kind of the purpose of the webinar, to show you two kind of GIS platforms. And at the first one, Graham shared with you what you can do with Esri ArcGIS using CDP data and how you can do it. So he showed you kind of the all the components of before importing the data to the ArcGIS and also ArcGIS software. In this presentation, I am going to show you what you can do with QGIS. We are not going to go through the QGIS software and kind of, how to do it. But if there is some desire from the kind of members to learn how to do it or want to go through the same level of the work that Graham showed, we can design another webinar for it. But this is kind of, I go through the purpose of this project for sure, but at the beginning, I wanted to mention that this is the kind of the purpose of my presentation is, show you an example of a QGIS project I've done with the working in an open kind of source mapping software, and also using the open data sets that NRCan or Natural Resource Canada data sets. So before going to the actual kind of the examples of the project, it's good to provide you a very brief introduction about the project. It's a very interesting project, and it's based on the natural resource reports on the physical exposure and social vulnerability to natural hazards. And then the report was done in 2022. So we are not going to go through the details of the report. We just going to touch it to kind of understand how the data works and what indicators from these kind of items we used for QGIS project. So just touching it and not going to go through the project. But at the top, you will see social vulnerability and the social fabric. That's kind of items that will be it's important in the times of natural hazards or natural disasters. And then on the right, you will see physical exposure, that we focus on that in this, and the buildings, assets, and people that are part of the kind of important components that will kind of, when it comes to the disasters, are important to study that. So the purpose of this report was that to create an integrated hazard thread that combines measures of social vulnerability and physical exposure models that developed by Natural Resource Canada to measure the susceptibility of buildings, people, and financial assets to known natural hazard process in Canada. And as mentioned, that's a kind of the project that's been done it was done in 2022 to make this model. For that, so just a very quick kind of review of this. And I will put the resources usually at the end, but for this, I wanted to show you that the reports we used in this project, that the physical exposure to natural hazards and social vulnerability to natural hazards in Canada 2022, and then the link to the data. The geography also is interesting because the geography that's been used here is a bit different from what we used to work with. So it's smaller than dissemination area. It's called settled area, SA, which represents one or more permanent building footprints within a standard census dissemination area. And we will, if we get to that, we will talk about it at the end, that there are kind of some indicators that are in bigger kind of geography, larger geographies, and we need to do comparisons. So how we can kind of turn this settled area into the economic regions, for example, census subdivisions. So those kind of the experiments we've done, and we will share you if we get to have time for it. So as at the two slides before, I talked about social fabric and social vulnerability. this is kind of, again, that's we are not into the my project yet. This is kind of a report that you will see the components that made this social vulnerability profile in settled area in Canada on the right, and all the different components of it. That settled area classification of broad settlement types is Canada, that I will show you in more details in later kind of slides, but just touching the report. And then the other one that I mentioned, the physical exposure, also at the top, you will see all the factors that go into to make that physical exposure that shows, for example, high, moderate or low density, and then the when it times to the disasters. So these are important part to make that hazard threat, the model that Natural Resources Canada made in 2022. So in both social fabric and physical exposure, one component is in common, and it's settlement areas. That's one I want to show you, and also I added the data to the QGIS later. So the settlement area types it's kind of the assessment of physical exposure and social vulnerability in Canada is structured around a mosaic of 8 fundamental settlement types that are distinguished based on characteristics of size, geographic setting, and level of hierarchy within broader socioeconomic system, and it's data from Stats Canada in 2016. Each settlement type is defined based on a statistical area classification, or SAC, that groups census subdivision according to population density and whether they are part of a broader census metropolitan area or census agglomeration, or distributed within less dense rural or remote setting with variable degrees of metropolitan influence. And at the left side, you will see 3 major kind of settlement types, and then kind of subgroups of each, so metropolitan, rural, and remote. So so that was kind of the very brief introduction of the report that Natural Resources Canada has done, and then we use the data to that's, I see a question. Yes, the project is publicly, that's our project, the Natural Resource Canada project is publicly available, and I linked it in our presentation slides for you to look at it for sure. It's a very interesting project. So for this presentation, we wanted to integrate multiple spatial datasets covering urban centers and rural remote communities across British Columbia using this QGIS as an open source GIS platform to test the applicability for a risk assessment tool. So this is what I'm going to show you. This is kind of the testing part of the whole project that's still in progress, so it's not done. And we wanted to test it and see actually feasibility stage of this project, that we found QGIS is the best, as it's an open source data, open source platform. So that's easiest to kind of test and experiment and see if it's feasible to continue this project in the later in Tableau or other kind of softwares to have more comprehensive, integrated, and accessible visualization. And we use that in NRCan's open data disaster risk reduction, the natural human settlements layers. That's, I put the link in our presentation slide as well, to describe physical and social characteristics of urban centers, rural, remote communities. And this is what I got from the data that was a settlement area types that I showed you in 2 slides before. I imported it into QGIS. Oops, sorry. And you will see that the settlement types that's shown in dots and in different colors, And this is British Columbia, the province of British Columbia. And the darker blue shows the metropolitan, the urban centers that we see more in Lower Mainland, as Vancouver, Victoria. And we have other metropolitan types. The rural types, a strong influence or big influence by metropolitan. That's in different colors from yellow to orange. And then the green ones is the remote areas that we see less in Lower Mainland and more in northern part of BC. So with that, I will kind of show you the indicator things that we developed to test the data sets and kind of go through a feasibility part of this project. As I already mentioned, the physical exposure and the social fabric. And we used, there were more than indicators than you see on the screen. That was 20 more indicators, but we chose these to kind of test it on in QGIS. So land use classes, we go through it, building density, daytime and nighttime population density. And for social fabric, we kind of went through the social vulnerability score that I will explain in more detail. So the first one is a land use. So land use class is assigned land use for the settled area based on population density, census housing characteristics, and the North American Industrial Classification System codes. And we add the data we got from kind of NRCan data to QGIS. And this shows only the trying to move this along, only shows the city of Victoria and surrounding census subdivisions. And with that, we get to, we visualize this data, and also even we added some kind of charts to better understand the data. And you will see a different land use classes that in Victoria, we see more residential and also mixed. And then surrounding, we have a commercial, and very top, away from Victoria, we see some rural classification. But the chart also show that only for city of Victoria, that the 52% of residential medium density. The next indicator we went through was building density, average number of buildings per square kilometer. And that's what we got when we imported the data. Again, in the same kind of geography, we are going through the city of Victoria and surrounding CSDs. And that's showing the city of Victoria has the highest building density here. Daytime population density, that's is estimated average number of people in buildings during standard work hours, 9 to 5 p.m. per square kilometer. So this one shows that the daytime population density, that's kind of in different areas with different colors, that the blue shows the highest density, and if it gets to yellow, orange, and red show lowest density here. And nighttime population density, that's one of the indicators of the physical exposure that is important to know when it comes to disasters and modeling kind of the hazard. That's estimated average number of people in building during nighttime hours, 8 p.m. to 6 a.m. per square kilometer. So kind of showing the kind of the residents of that area. And here we see slightly kind of changes from the daytime. So the blue here is one level lighter, and almost the colors are one level lighter. So that's not a very big kind of shift, but still shows the differences. That kind of in daytime, there are definitely more population than nighttime. And then the last indicator thing is social vulnerability score that has different components of it. So for this, it's kind of important to know what does that mean. So the social vulnerability score is that's the combination of indicators to represent the settled area relative level of social vulnerability compared to other settled areas of the same community archetype across Canada. And you will see that different kind of items that affect the social vulnerability score, like social capital, individual autonomy, housing condition, and financial agency. And thinking about that as one of the important factors when it comes to the natural hazards. To kind of model it and also in order to see the kind of a population that needs support before or after the kind of during or after the kind of hazard is happening. And for this, see that if it goes, yes. So this one is showing the social vulnerability score indicator in this, the geography is settled area within the city of Victoria and surrounding census subdivisions. And we see that kind of the level of social vulnerability, the darker it's extreme, and if it get lighter, it's kind of low, a low kind of lower vulnerability to natural hazards. And one of the things that I mentioned earlier about the settled area and then the geographies is that if we want to compare it in the census subdivision, in the economic region or census division, we need to come up with some calculations to that get the accurate number instead of having it in a small kind of settled area like you see in this image. And there are, the Natural Resource Canada kind of suggested a methodology to go through that. We work with two other kind of calculation, the mean and the average, weighted average. And then we came up with a conclusion that I will share with you as our final kind of presentation slides here. So this is the calculation that's on the report of the Natural Resource Canada, and they use that kind of aggregation to get to this level of for the larger geographies, CST, CD, and ER. And this is the result when we import that data. So you will see that we see City of Victoria as a whole, we see different CSTs as a whole instead of small kind of in a small geographies like in a settled area. We also thought that maybe mean of social vulnerability scores of clustered settled areas in a CST, CD, and ER might give us a better kind of response to that. And as I mentioned, that's kind of a testing area. And this is kind of the purpose of it, show you what you can do in QGIS. So we made that calculation and we got the almost similar response as the methodology in NRCan report. And then the last one we tried was the average of social vulnerability scores of clustered settled areas in CST, CD, ER rated by night population. So that's kind of the more residents of those places. And we use that formula in QGIS. And we get to this result that's slightly different from what we saw in two other slides. And at the end, we kind of something that we call, as a kind of the sum up of these methods we use, or these testings that we if that project will kind of continue in a longer term, we are going to work on that, is for more accuracy and not neglecting any important factors. We think that we want to import this data without any changing, so that would be the settled area geography, but imported in Tableau, and that the kind of in Tableau dashboard, and that dashboard would display the social vulnerability for clustered settled areas in CSD, CD, and ER, along with other social indicators that I mentioned that we only used one. So in order to be more accurate, so we need to see all other indicators along with that social vulnerability score. And it's the best would be to kind of see that, to see that with the settled area, along with the 20 social indicators that impact the social vulnerability scores. So that's a kind of overview of this project we've done, and thank you so much for listening. I will stop sharing and see if anyone has any other questions. Yeah, thank you so much. So the question is, how do you get the nighttime data? What is the source? Is it connected to nighttime satellite imagery? So that was the data we got was from the Natural Resource Canada, that they kind of I definitely recommend that reading the report to kind of for more detail, but it's a very good question. That's kind of how they got the data, but it's based on the that's the timing is 8 p.m. to 6 a.m. But for more details, yeah, kind of definitely recommend that reading the reports that how they got the data in terms of this, using satellite imagery or not. But yeah, but that's definitely good question. And if I found it, I definitely share with you the results. Oh yes, so I would say that's the question is, how did you learn how to use QGIS? And because I had a background and I learned kind of ArcGIS, so I started QGIS just without any other courses. So just started, and there are definitely some components in QGIS that's totally different from Esri ArcGIS. There are some plugins that you have to install in order to do some kind of make some actions or do some kind of stuff there. So I kind of learned as I needed anything to do, and that was Google searching was the best. But there are some kind of open to public kind of YouTube's videos that can help to how to. So I kind of responding to your question, Graham, is that I searched it, and if I had anytime any questions that it was not what I used to do in Esri ArcGIS, so I had to search it. And because the QGIS made by there are different version of it that will be updated once a while, and there are people that work volunteers working, so they put some frequently asked questions on the QGIS website, and you can, when you search it, that will come up, and you can kind of find it. That's something like it, because it's open source. That's kind of definitely, and they are experimenting and they are making changes and everything. So there are great resources on the QGIS website as well. Thank you. So how were the index scores in the different categories put in the same scaling system, low to extreme? That's that's kind of, thank you for asking the very detailed questions about the report. Report is very kind of rich, and they've done a great work on it to get to this point that I just showed you, this social vulnerability score, that just a number. So that was some sort of kind of research behind it to get to that point. And I can share the screen to show you the part that was showing how that social vulnerability components that affect that. So I am not the right person to explain it, because that there are different, we use this information and we just touched the report. We haven't gone through the report in detail because we just needed the data, but we wanted to know what's happening with that and then use it. So that's something like here they are, definitely some calculations happen that you see the different components, and then the social capital, individual autonomy, housing condition, and financial agencies. And these factors that kind of affected to make this index that just comes to low to extreme. And also something I wanted to add, that the low and extreme, it means that social vulnerability, lower social vulnerability to natural hazards, or extreme social vulnerability to natural hazards. So if there is kind of the age of a person that's a seniors living alone and not very much autonomy, so probably they are more kind of, needs more support when it comes to disasters. And that's the model wants to get to the point that in those areas, definitely there's more support needed in some areas of town, or some areas of remote areas or rural, when it comes to disasters. I am not sure if I respond to your questions. I tried my best based on my knowledge, but I'll definitely recommend to read that social fabric report that made by Natural Resource Canada. Thank you. Perfect. Okay, great. Is there any other questions about this? Any kind of, if you have any requests for future webinars, any specific topics that you would like to see that, maybe more more in detail about QGIS or how to do it, please let me know. You can always email me at sadie@communitydata.ca. For anything about webinars,